Okay, so yesterday we discussed. Where's my pen? Yesterday we discussed about application of derivatives, and almost we covered everything about AOD. So in today's session, there are like we were earlier discussing about straight lines. So there's one more concept about straight line which I would like you for you to revise it. That is the angle between two lines. Yes, here. So here let's discuss. There are like two lines. Say line one and line two, line two and line one. This line one's slope is m1. This line two's slope is m2. So if we have to find out the angle between these two, so we can write as tan of theta would be m1 minus m2 upon 1 plus m1 m2. So if we have to find out theta, it will be what? Tan inverse m1 minus m2 upon 1 plus m1 m2. The concept of angle between two straight line. Okay, is this clear to you?
Yes, sir.
Why we have written tan theta here? Can you tell me what is tan theta? Why exactly tan theta is here?
Sir, because we have to find the angle, sir. Because it was a lines.
Yeah, kind of, yes, right. And tan theta is also like your slope.
Yes, sir.
Okay, so as we are discussing about like these two slopes, so as if considering this m1 is greater than m2, otherwise we can just write, we can just take its modulus. So it will be giving us the angle between two straight lines. Now it is the same case with tangents also, because tangents are also straight lines where one tangent's slope is m2, another one's is m1. So we can find out the angle between those two using the same energy, right? Okay,
Sure.
so there were some other concepts. Basic theorem of Lagrange and Rolle's theorem were left, and another one is that we had to find out the length of tangent, length of subtangent, length of normal. So let's discuss those one by one. Any doubts regarding previous lectures?
No, sir.
Okay, so going back. Here is Rolle's theorem and here is Lagrange's theorem. So let's discuss Rolle's theorem. It's very simple. That its statement is like if a function is continuous in the closed interval means that a and b both are included, and the function is also differentiable in open interval a b. That is differentiable at each point in between these a and b. Okay, and the value of function f of a and f of b are equal, then there will be at least one point in C in the interval that f dash of C is 0. Actually, this diagram is wrong in the book, where it should be C and here it should be B. Then f of A and f of B are equal. And the function is also continuous in between A and B and including A and B also. And it is differentiable in between all the points between A and B. Okay, and the value of function on A and B are equal. So these are three conditions. If these three conditions stays true, then there will be at least one point in the interval where uh, the slope would be zero. So here you can see f dash of c, slope is zero. That's all about Rolle's theorem. Clear?
Yes, sir.
Great. So let's discuss this example later. First, let's discuss about Lagrange's mean value theorem. Its statement says that if a function is continuous in the closed interval a b, again, there's a misprint. Let me see who's honking. Okay, so yeah, in this function, it is continuous in the closed interval. A and B both are included and differentiable in open interval. So it is the same condition with these two conditions are the same, but f of A and f of B are not equal here, as you can see from the diagram also. So this
Yes,
is
sir.
the only different situation. And then f dash of C would be equal to f of B minus f of A upon B minus A. Means it is trying to say that its derivative would be somewhat equals to this, where change in y, because f of B, f of A is what? Y, and change in x. So basically it is trying to say that the function's curve would be somewhat straight line. Though we cannot directly say this, but we can understand it using uh, this relationship. Is this clear, everyone? Is this
Yes,
clear to
sir.
you?
Yes, sir. Sir, actually,
Yeah.
uh, I was started in the maths actually started in sets and relation functions, sir.
What?
I actually started the lesson of sets and relation and functions, sir.
Okay.
So actually, I want to clear that concept, sir. So if today is I'm the only one in the class. Can you please say that, sir, instead of this, because I yet not started this.
Okay. So do you want to me like do you want me to
I
repeat
want to
it?
no, sir. I want to change the topic because this is actually new for me, and because a lot of efforts are you're putting in. So I need to utilize it properly. So that's why I'm saying that, sir. Please explain me instead of this. Explain me that sets theory and functions, sir.
Okay.
Because I've started and I'm practicing on that, so that I can more practice and I can more understand it in that way.
Okay. So like we can do it in the like in the last 20 minutes. Okay.
Okay, okay, sir. So
Because we also have to continue whatever syllabus is going on.
yeah, yes, sir. Definitely.
Yeah.
So
So
saying, sir, that I am not ordering like don't
uh,
misunderstand me, sir.
okay.
Sir.
So this is about Lagrange's mean value theorem.
So
So I guess this completes our chapter. Yes, there's one more concept of remaining of the length of tangents and the subtangent. So basically these will be nothing. You just have to remember some formulas for finding length of tangent and length of subtangent. Here it is. So for finding the length of tangent, you have to first find out, basically you have to find out why it is, and all those values will be known to you. Just substitute those values in these formulas and you'll be getting length of tangent, length of normal. Length of normal is what? Tangents, if this is a tangent, so the normal would be very much perpendicular to it. Length of normal and length of subtangent, length of subnormal. Okay, we can
so
use these formulas to find out. So this completes our chapter theory. So let's now first discuss about the examples, and let's solve all those examples. Example number 3 we have already discussed. Yes, example number 3 we have already discussed. Let's discuss the example number 4. Try to recall concepts from class 12 study, Raja
So
Krishna, and relate those. Okay.
yes, sir.
Okay. So as in this says the interval in which the function f of x is equals to x plus 2 e raised to power minus x is decreasing. So basically we have to find out interval of x, है ना? And we have the function. So function will be decreasing when it is less than 0, right? So let's first find out the f of test of x, and let's consider this as u, this is v. So if we are taking UV's differentiation, then U dash V plus UV dash.
We did.
Yes. So it would be 1 into e raised to power minus x plus e raised to power minus, sorry, U as it is into differentiation of e raised to power minus x, e raised to power minus x into differentiation of minus x. So e raised to power minus x can be common. 1 plus x plus 2 into minus sign. There is minus sign here. So let's erase this. So
Sir,
minus
why one is came, sir? You
क्या?
पहले जो आप एफ डैश एक्स में जो एक वन लिखा था ना सर,
Hmm.
उसमें वन कैसे आया?
Here,
हाँ हाँ सर.
yes. So UV dash when we are like differentiating the product of two functions. So when first we will multiply the derivative of the first function, the second function.
Oh.
So the second function is as it is, and the derivative of x plus 2 is 1. Derivative of x plus 2 with respect to x, derivative of x is 1. Derivative of 2 with respect to x is
Sir,
0.
you are what?
Yes.
सर
Was
आपका वॉइस स्टक हो रहा है सर.
okay, okay, no problem. I can repeat. We had to differentiate the function of the product of two functions. That's why were applying this particular formula in which we had to multiply the derivative of first function to multiply it with the second function. So u dash of v x plus 2's derivative 1, because the differentiation of x with respect to x would be 1. The differentiation of 2 with respect to x will be 0. So 1 plus 0, that's why 1 is here. Okay, now is this clear to everyone?
Yes, sir.
Yes. And please unmute both of you, and please keep on responding so that I know students are there and listening. So further, is for minus x, 1 minus x plus 2. So 1 minus x minus 2 will become is for minus x, 1 minus x. So taking minus common here, 1 plus x. So this is what? F dash of x, right? And it should be less than 0. So 1 plus x should be less than 0. Now, this particular term to be negative. First, let us first all understand that e raised to power anything would never make it negative. This will always be positive. Why? Because e is a positive number. And if you like, let's say 2. If you put any power, any real power to 2, it will always be positive. If you even put minus 2, so it will become 1 by 4. It is still positive. So is this clear to you?
Yes, sir.
So this particular term to be negative, minus 1 plus x should be negative. Now on multiplying minus on both sides, the inequality will be reversed. Then further simplifying it, so x should be more than minus 1. So on number line, this is minus 1, this is plus infinity, this is minus infinity. So more than minus 1 would be this. So minus 1, excluding minus 1, 2 plus infinity. And
Infinite.
infinity is also excluded. So the A
Option.
option is correct. Is this clear, everyone?
Yes, sir.
Yes, Nandana, is this clear? Please unmute yourself and speak. Okay, so let's now move on to the next example. Here it is. Example number 5. The equation of the tangent to the curve at the point of its maximum is. So basically, this is the equation of curve. Now we have to find out the equation of tangent. In equation of tangent can be find out by first we need to have its slope. Okay, slope can be find out by basically derivating the given function of the curve. And we also have to have one function. So, sorry, one point. So let's say that this is the curve of the function, and we are discussing about maximum point. So we are drawing a tangent over here because we are drawing the tangent and and at its maximum. So here this particular point would be lying on both tangent and as well as function of curve. Okay, so you will get to know that how will I find out the particular point. So let's first discuss about the maximum condition of this function. So first, for finding its maximum or minima, we have to let's use second derivative test. So first differentiating it, this is first function, second function, u dash v, it is 2 plus u v dash e raised to power 2 1 minus x, because derivation of ex with respect to ex is ex only. Now differentiation of this particular 2 to 1 by, so 2 is a multiple, 1 minus x, one's differentiation is 0, minus x differentiation is minus 1. So simplifying it, it's minus 2 into 2x minus 1, 2 is to power 1 minus x. So this is what f dash of x. So let's find critical point. For critical point, we used to do f dash of c is equals to 0. So let's make it 0 and find out the value of x. So 2 raised to power 2 is 1 minus x minus. So if it is minus 2 into 2x minus 1 is power 2 1 minus x. So let's bring this particular term on the left hand side and it will become positive. 2 into 2x minus 1 is to 2 1 minus x equals to 2, so 2 1 minus x. So now we can do one thing, is that we can simply cut the e raised to power 2 1 minus x. Otherwise, you can also take it common, because there is a condition in. Let's first bring this whole equation on the next page. Let's take e raised to power 2 1 minus x common. So become 2 minus into 4x minus 2. This will become minus 2 and further it will become plus 2. 0 is equals to p raised to power 2 1 minus x into 4 minus 4x. 0 into 4 into e raised to 1 minus x. We have taken 4 common from here, 1 minus x. So for this product to be 0, either this 0, either this is 0 or this is 0, or both are zeros. So any like number raised for anything cannot become 0. Never, never. It will never happen. Okay. So this have to be 0. For this have to be 0, x is 1. This is our critical point. Okay. Now let us, so in second derivative test, first step is to find out the derivation, then to equate it to something 0, then x would be x, the value of x would be the critical point. Then to find out double derivative and check for its sign on C. If it is positive, then it is a case of minima. If it is negative, then it is a case of maximum. So this is about second derivative test. We have done these two steps. Now let's double differentiate the function. What was f dash of x? F dash of x was this. Okay. So first, let's bring it. Laptop is stuck. Simply, let's take its derivative. 2 would be as it is in the multiple. So e raised to 2 1 minus x. So it is an exponential function. It will be same into the derivative of this. So 2 into derivative of this. Okay. So let's now discuss about the derivative of this 2. So this is u, this is v minus 2. So minus 2. U dash is what? 2 into v plus u into v dash. V dash would be, as it is an exponential function, so it will be same to the multiple to the derivative of this 2 into minus 2. Okay. Yes. Minus 2 is outside. So let's now we have to find out for it's like we have to substitute x for c. So why not doing it here only? So our critical point was what? 1, right? So let's substitute x is equals to 1. So we can see there are some general terms like e raised to power 2 into 1 minus x. So let's put x is equals to 1 here. E raised to power 2 into 1 minus 1. So it makes it e raised to power 0. So it is basically 1. So this is all going to become 0. Sorry, 1. So all going to become 1. So all going to become 1. So all going to become 1. And we can also see 2x minus 1 here. So it would be just simply 1. This is also 1. And okay, so let's now solve. F dash of C. It's 2 minus 2 minus 2, 2 plus 2 minus 2. This is minus 2, right? So this becomes 0, becomes minus 4. There's a negative value. So yes, on x equals to 1, the function will be having maximum condition. So now we have a point x is equals to 1. Okay. So we have a point that x is equals to 1. We have to find out its coordinate on y. So as this point will be lying on the function also, as it is lying on the tangent also, so it will be also satisfying the equation of curve. So we can find out y's value from here, right? Can any one of you tell me the value of y? What would be y here? Come on. It's very simple. Anyone? Okay, simply putting x here, x is equals to 1 here. So y would be 2x minus 1. So 2 minus 1 into e raised to power 2 into 0. So this becomes 1. So e raised to power 0 becomes 1 and 2 minus 1. So basically y is 1. My laptop was stuck. So is there background noise from my side? Is there any background noise from my side? Okay. Yeah. So where was yeah, 2 into e raised power 0, it will become, sorry, 2 minus 1. So it will become 1. So now y is 1. And what is the slope? Please tell me this. What is the slope? I have an expectation from you. You can directly see from the map. It's a maxima. Slope is like this. So just tell me the what will be the slope here. And no problem if you even give the wrong answer. Please try. Yes. Yes, Raja Krish. Yes, Nandana. Speak.
So can you repeat it again?
What can I repeat? Please tell me what should I repeat?
Hello.
Hello. I guess there is a network problem from you, Raja Krishna. I'm asking you, what should I repeat? Please tell me, I'll do that. Your voice is not audible. Is this clear, Nandana? Uh, the slope would be 0. Why? Because the slope is simply like there's a maxima over here. So definitely the slope is going to be 0. Otherwise, we can also find out that on f dash of x, if we put x is equals to the critical point, which was that, so it is going to equal, it is going to be 0. So basically now we have slope and the point. Now we can find out the equation of tangent. So earlier we have discussed the equation of line when we have slope and when we have a point of that line. So the basically the equation of line is what? This. Simple, as simple as that. So here we have y as what? 1. X is what? Uh, another one. And slope is what? 0. So y minus 0 into x minus 1 into 0, 0. So y is equals to 1. It is the equation of tangent here. So answer would be B. Is this clear to you, everyone?
Yes,
Please
sir.
keep your pen down. Please, if you have any doubt. What we have done in this question, we have used second derivative test. What is second derivative test? First of all, we have like looked out for the point that on which point the function would be maximum. And let me tell you one trick. Okay, don't tell this to anyone. Whenever we are finding the critical point, and when it is 1, and most of the time when it is given in the condition that it's maximum minimum, you do not need to check it. Okay, most of the time, like 100% of the time, it stays true and the condition satisfies whatever it is given in the question. So you just have to find out the critical point and then just go on to solve this question. So after finding critical point, what we did is that we already knew the slope. We had to find out the point. So we had x as a variable. We had x as a variable already. So we just put it x into the function of curve because it is also satisfying the function of curve. So that's how we find out the value of y. Is this clear, everyone, or should I like more explain how did I particularly do this and what is the concept behind this? If you say, I'll do that, no problem. Yes, any doubt? Yes, any doubt? Am I audible?
Sir, your voice is little low.
Your voice is very low. Could you repeat?
Sir, I couldn't hear you, sir.
Clear. Are you saying clear?
Yes, sir.
Okay, great. Then let's discuss the next example. Example number 6. The point on the curve. The point on the curve 3y is equals to 6x minus 5x cube, in which the normal is passing through the origin. Now we are talking about normal. Okay, heat. So this is the curve. So let's consider that this is any curve, and the normal is passing through the origin. Okay, so here if a normal is drawn and it is passing through the origin, it is given. So we have to find out the point on the curve. Okay, so in which the normal is passing through the origin. Okay, so let's consider the, let's draw a graph. And let's say this is some functions curve. Okay, this is the given functions curve. And we have drawn a normal on this. We have drawn a normal on this, and that normal is passing through the origin. So basically what we are saying here is that the normal, that is a straight line also, it is passing through origin. That's what is given in the question, and this particular functions equation is also given. Okay, so it's simple. As we know that it is a normal and it's passing through some point, so this is a point. So let's now first find out its tangent slope, then we'll be able to find out the slope of this normal. Okay, because we know what is this, -1 by dy by dx, because if there are any like two straight lines of slope m1 and m2, so their product of slopes is going to be -1. Okay, so now the like saying we know the slope of tangent. Okay, and we know tangent and normal are perpendicular, so the slope of normal would be -1 by dy by dx. So is this clear to you that how is the slope of normal is coming out like this? So let's differentiate it further. Okay, 3 into dy by dx, 6x would be 6 minus 5 into 3 into x square. I guess this is clear to you. Okay, so dy by dx would be simply dividing the right hand side by 3. So this is the slope. This is the slope of tangent. So now the slope of normal, it would be simply -1 by 2 minus 5x square. So we can multiply -1 on numerator and denominator. Now we have the slope of normal. Now this particular straight line, we know one point on the straight line, which is what? 0 and 0. Is this true? Are you able to understand that we know two things about the straight line right now? There's a point and there's a slope which we have just calculated. Is this clear, everyone? Are you with me?
Yes, sir.
Yes, sir. Yes, sir.
Okay, great. So now we have two information about, so we can write the equation of this straight line, which is known as normal. Let's do it on the next page. So y minus 1 point was 0, another point was 0, and the slope was 1 by 5x square minus 2. This was the slope. So let's multiply, cross multiplying x. Okay, so this is the equation of straight line, the equation of normal which we have. Now we know we had to find out the so now there are two curves, there are two functions intersecting each other. So when two functions curve intersect each other, their intersecting point would satisfy both the equation of straight line and also this curve, right? So let's see if we have done any mistake or not here. Yes, yes, no mistakes. X by 5x square minus 2. So this is the equation of straight line, which is r normal, and the equation of curve is already given to us, which is what? 3y 3y is equals to 6x minus 5x cubed. So these two equations are intersecting for a point which would be common to both of them. Okay, so what we can do, we can substitute the y value of y in here. So 3 into x minus 5x square minus 2 is equals to 6x minus 5x cubed. So now whatever the value of x would be there, so it would be the intersecting point of these two functions. So let's say x1 and y1. So here, whatever the function of x1, x will be coming, it would be x1. Okay. So from here we can see, like, we can cut x on both sides and it will be 2 here. So let's simplify it further and cross multiply it. 5x square minus 2 into 6 minus 5x square. Yeah. So have I made any mistake or not? No, no, no. Everything is correct, I guess. Yes. 3x 5x square minus 2, 6x minus 5. Okay, great. So let's solve this further. And we had to, so multiplication should be equal to 3. Okay. Okay, yeah. Oh, yeah, yeah. So what if x is 1? Let's hit and try. 3 is equals to 5x square minus 2 into 6 minus 5x square. So we can simply see here, if we just don't see x, so it will become 3, and 6 minus 5, it will become 1. So let's substitute for let x is equals to 1, but let's see if this satisfies or not. 5 minus 2, 6 minus 5, that is 3. So LHS RHS is equal. So yes, for x is equals to 1, this particular thing would be satisfying. So if we have x1 is equals to 1 right now, we can find out y1's value. We can just substitute by x1 or x value in both of any one of these terms. So let's do it with the first equation. So x upon 5x square minus 2. So 5x square 1 minus 2. So basically it becomes 1 by 3. So now we have the point 1 and 1 by 3. Let's check if it matches with any option. Yeah, it do. So A is the correct answer. Are you able to understand this complete question? If you have any doubt, you can ask me. Please ask if you have any doubt, any minor doubt, anything. So let me recap what we have done in this question. That first we understood what this question is saying. That this is a function, this is a curve equation which is given to us, and there is a normal passing to on the equation which is also passing through the origin. So now there is a straight line, there is a curve. Okay, and we found out the slope of this straight line using our formulas, and this I have taught already in the earlier classes, and I also repeated here also. So we have find out the slope of the straight line, and we already know there is one point, and which is 0, 0. So we find out the equation of normal, and then we had the equation of normal and the equation of curve. Then we like substituted values of x and y intersected, and we find out the value. Sorry, we find out the point which is an intersecting point. That is what we were supposed to find out in this question. Is this clear, Nandana?
Yes, sir. It's clear.
Is this clear, Nandana?
Yes, sir. Do you
Okay.
need, sir?
Anything? Yes.
Sir, it's clear, sir.
Okay. So let's move on to the next example then, if so. Yes, answer is A. It's correct. Let's discuss about this question. The angle of intersection of the curves y is equals to x squared. 6 and 6y is equals to 7 minus x cubed. So now we have to find out the angle of intersection between two curves. So basically, let's say this is some coordinate plane, and these are two functions. Okay, now we have to find out the angle between these two on this particular point. So what we will do, we will simply take the tangent of first function into the, sorry, it's not a straight line. We'll simply take the tangent of the first function here. And we'll simply take the tangent of another function, second function, like this. Okay, now we will find out the angle between these two tangents, and that would be equal to the angle between these two curves. Is this clear? Is this concept clear to you? Yes, please unmute yourself and speak. Raja Krishna is saying, sir, sorry, I could not join the class. I lost my signal. Then how is he able to message? No problem. Anyways, is this concept clear to you, or should I explain it once again?
Sir, it will be better if you explain once again.
Please speak clearly and like loudly.
Sir, it will be better if you repeat it once again.
Okay, understood. So let me just explain it once again. So there are two functions. Like say this is the curve of first function, and let us say this is the curve of second function. Let me draw it some more. So in this question, we have been asked that we have to find out the value, the angle between these two function on the point of intersection. The point of intersection is this. So what we are going to do, that we are going to take the tangent of one function and the tangent of another function, and we'll just simply find out the angle between these two tangents, and that will be the angle between these two curves. Okay, these are tangents. This is also tangent of other curve. So how we will do that? Simply, we know that we can find out the tangent of one function by taking its derivative, and another function by taking its derivative also. We know the derivative is, sorry, it's not tangent, this is slope of tangent. And we know this is also slope of tangent. And we know slope of straight line is equals to tan of theta. Okay, so basically what we will be having, we will have tan theta of 1 and tan theta of 2, and we need to find out theta minus theta 2, and that will be the angle between these two tangents. So how we will do that? Let's take its tangent, and we know this is a formula. And we know tan theta 1 is what? M1. Tan theta is 2. Is this 1 plus m1 m2? So theta 1 minus theta 2 would be what? Theta 1 minus theta 2 would be what? Tan inverse of m1 minus m2 upon 1 plus m1 m2. Simply. Is this clear to you, Nandana? That how we are finding the angle between two functions.
Yes, sir. It's
Is this
clear.
clear?
Yes, sir.
Great. So now let's find out its functions. Sorry, its slopes. Here, let's do it here. So whatever in green was the concept. M1. The first function was what? Y is equals to x square. So differentiating y is equals to x square. The other function is what? 6y is equals to 7 minus x cubed. So taking its derivative would be 2x simply, right? Wait, let's. My laptop. Now to finding its slope, let's first derivate this dy by dx is 2x. And now here 6 into dy by dx would be 7 0 minus 3x square. Is this clear to you? So this is dy by dx. This is the slope of tangent, which is 2x. Here's dy by dx would be minus 3x square by 6 will become minus x square by 2. So to find out the slope of the tangent on this particular point where these two functions are intersecting, first we have to find out its intersection point, which would be x1 and y1. We are calling it as. So for that, we will simply do the function second, and we can equate it with the function second, with the second function's curve. So those points which will be coming out, that will be the intersection point. So let's y is equals to x square. So let's substitute y is equals to x square in the second equation. 6x square minus plus x cube is equals to 7. X square common 6 plus x is equals to 7. Now for this to stay true, how should we find out further? Okay, so let's do one thing. Let's hit and try like earlier also, as we can directly see that if you take x is equals to 1, so it would be 1 into 6 plus 1, that is 7, 7. So LHS, RHS equal, so x is equals to 1. That's the desirable point. So we had to find out only one intersection point, so why worrying about other solutions? So as x is equals to 1, so y's value would be y is equals to x square. So y will also be 1. So we have the intersection point for x is equals to 1, y is equals to 1. So the slope of the tangent and on the intersecting point would be m1 is equals to 2 into x, which is 1. m2 would be 3, sorry, minus into x square, which is 1 square by 2, basically minus half. So let's now put the values on this in this particular function and solve. 2 minus of minus half would be positive. 1 plus m1, which is 2 into minus of half. 2 cancels 2. So 1 minus 1, it would be tan inverse of 3 by 2 by 0. So basically this is infinity. Tan is infinity on pi by 2 angle. Okay. So the angle between those two curves would be pi by 2. Is this clear to you? Any
Yes, sir.
doubts?
No, sir.
Yeah, so simply let's break down it into points that we have to just find out the slope of these two, slope of the tangent of these two functions, and we also have to find out the intersecting point. Intersecting point can be find out simply by equating those two functions. Okay, and thereafter we can simply find out the slopes by differentiating the function dy by dx, and later on substituting for the values in x and y in the dy by dx here. Okay. So if it's clear, let's move on to the next question. Example number 9. Example number 8 is here. 9 is back. Okay. So let's solve this 9 only. It is first. The maximum value of f of x function is given in the interval. So let's simply do one thing. Let's apply. Yes, as we know, like the period is very much given in front of us, and the interval is very well defined. So we know on maximum, on like whenever the function is maximum or minimum, the the slope of the tangent, is 0 on maximum and minimum also 0. Okay, so let's take its derivative, f dash of x, 2x cube, so it would become 3 into 2, 6x square, minus 24, x means 24. Its constant derivative would be 0, so it would be nothing. So equating this is was 0, 24. So 24 into 6 x square, 4. 4 is equals to x square. Basically, x comes out to be plus minus 2. Is this clear to you? How is this possible? Okay. Now x is given in the interval of this. So we cannot take minus 2's value. So this x is just plus 2. So the maximum value of f of x. So let's just like substitute f of 1 and f of 2. Okay. So let's find f of 2, which must be like it's at its maximum. So what we have till yet find out. Let's use the second derivative test simply. Now we have the function plus 2 and minus 2, and we have already find out f dash of x. Let's find out f double dash of x. F dash of x is this. So 12x is this. Okay. So for x, we had the x plus minus 2. Minus 2 is out of the domain. So for minus 2, x is equals to minus 2, which was our critical point. The function was having its maxima. Can you see this? For x is equals to plus 2, the f double dash of x would be positive, and the function will be having minima on this plus 2. So now this is a tricky question. So on the where the function is having maxima, we cannot take its interval because we cannot take this point because it is not in the given interval. This is 1, 2, 3. So now if we like say simply understand like on x is equals to 2, the function is something like this on minima, and we have a period from 1 to 3. So let's so it is damn sure that on x is equals to 2, the function is going to have some minimum value. So let's now find out for f of 1 and f of 3, which will be whichever will be the like maximum value, we can just mark the answer, right? Is this clear to you that why we are particularly going for f1 or f3, why we are hitting and trial? Because the double derivative test on which the function was maximum, the point which was x is equals to -2, the function of maximum, but it is out of our interval. That's why we are going and trying hit and trial method. Okay. Should I explain it once more? Please unmute yourself and speak.
Sir, it's clear, sir.
Sorry, could you repeat?
Sir, I got, sir.
Got it. Okay. But still, I would like to repeat it that we use second derivative test. Okay. And by that, we find out that on x is equals to -2, the function is having its maximum value. On x is equals to +2, the function is minimum. So -2 is out of the interval. So on x is equals to +2, function is having minimum value. So let's check for 1 and 3. Maybe it is having more value than that. So let's check for f of 1. The function was what? 2x cube minus 24x. Let's write it as like function here 2x cube minus 24x plus 107. So f of 1 would be 2 into 1 minus 24 plus 107. It will be 2 minus 24 plus 107. 107 minus 22. 585. Okay, let's find out for f of 3. 2 into 3's cube was 27 minus 24 into 3 plus 107. 2 into 27 is 44 minus 3 and 3 is 6, 72. No, sorry, 72 it will be plus 107. So 107 minus 12 minus 4. 12 minus 4 is 8. And then 6 minus 5 is 18. I guess I'm doing it correctly. 107 minus 18 would be what? 7 minus 8, 9. 17 minus 8, 9 minus 1, 89. So yeah, 85 is greater or 89 is greater? Please unmute yourself and speak. 89 is bigger or 85 is bigger? Second standard question. Nandana, is 85 greater than 80? Is 89 greater than 85?
Sir.
Yeah, so our answer will be 89. Okay, let's discuss example number 8. If at any point on a curve, question is not visible. If at any point on a curve the subtangent subnormal are equal, then the length of tangent is very. You can do it in the homework using these 4 formulas. It's a very basic question. Okay, length of tangent, length of subtangent, length of subnormal are equal, given equal. You have to find out dy by d. You have to find out simply dy by dx and y, and then substitute it in length of tangent. I think you can do it by yourself, right? Or should I do it? Oh, this is homework. So some good questions. The minimum value of px plus qy when xy is equals to r square. Okay, so it's a given function which is having binary variables px plus qy. So what is the obstruction here in front of us? Can you identify what is the problem here, that why we are not able to solve this question now? Because there are two variables in the function, and earlier we have discussed about the function having only one variable. So there's a condition also. So let's just simply substitute another variable. Phi is equals to r squared by x. So our function will become p into x plus q into r square by x. Now the function is only having one variable, which is x. So now function is having only one variable. So now simply we can find out its minimum value. Simply second derivative test, differentiating px p and then q r square 1 minus x. Understood? Minus 1 minus x is what? X raised to power minus 1. Minus 1 comes ahead. And then x raised to power minus 1 into minus 1 minus 1, which will become x raised to power minus 2. So it will go down in the denominator. It becomes the square root of x. So now let's now weight this equals to 0 and find out the value of x for which it is 0. Taking this on the left hand side equals to p. Now q r square by p is equals to x square. Further, q r by p. Okay, this is x. So now we have this critical point. Let's now differentiate it once more. Space. P's differentiation would be 0 and minus qr square is constant. Minus qr square into differentiation of minus x raised to power minus 2. So it will become x cube here. So this is 2qr square upon x cube. So whatever the sign of x would be, and it will decide the fate of function, whether it is going to be positive or minimum or maximum. So as given in the question that we have to find out the minimum value. So let's take the negative value of this. So what would be the negative value? As we know, whenever we take square root, so there is a plus minus here. So let's take the negative value of x, which is minus of q by p into r. Okay. So on this particular point, f double dash of x would be negative. So let's now find out the f of c to find out its minimum value. C is this here, critical point. So p of x plus qy, plus q into r square by x. R square by x, again x minus square root of q. Sorry, let's do it on the next page. We have this. Let's write here. So we have now the function and the value of x for which we have to substitute. F of x will become p into minus of into r into square root of p. Then multiply plus q into r square by x minus q into r square root of p. F of x. Are we going on the right path? I hope so. I hope so. So this cancels this. Why so? Because any like x can be written as square root of this, right? So we can write it as root x into root x. If you multiply it, divide it by root x, by root x, by root x, it cancels once and one root x remains. So here we can write root p, root q into r plus Again, this becomes like this. This cancels this. So there's a negative sign also. Square root of P, Q, and R. So basically it is -2 of P, Q square root of R. So let's check whether our answer is matching or not with any other options. Yes, it is matching, but there's a slight mistake that the negative sign is not there. So did we do any mistake? Let's check. For f of dash of x, we equated it to 0, then qr square by p x square. Now taking, there will be plus minus value. So further on, we took its double derivative, and double derivative was p's derivative would be 0. Qr square, there was a minus sign already in this. There was a minus sign already in this. So we have applied that. Yes. QR square into -1 to, so x -2 into -2 -1, it will become x cube. So yeah. So now the sign of x will determine it, whether it's going to be minimum or maximum. Okay, I guess there's a mistake in question also, because in question, I guess it's not considered whether it's positive or negative. If you find any mistake on this question in my solution, then you may correct me later. Otherwise, my final answer is this only. Okay? Now, I'm challenging this question, yo. Any doubts?
No, sir.
Any doubts? No, okay. Sorry, I didn't see the clock. It's 7:10 already. If you have any any different doubts regarding mathematics, you must be solving that. So you can ask me now. Anything about NDA preparation also. Any doubts?
Sir, no, sir.
No. Okay, great. So then let's conclude today's class. Okay. Good evening. Jai Hind. Thank you.